Thank you very much. Good afternoon. I agree with the executive chairperson that I will make this presentation in English. So we have an equal split of Korean and English speaking in this session. But as he introduced, I'm Korean, so if you have any question in Korean, don't hesitate. I can take it in Korean. Yes, and he also has explained I've been living in Denmark for the last 14 years. And I'm located in Aalborg as a northern part of Denmark, and as the headquarters of HGS system, as we call it, EMS systems in the Alfalaval's marine division. I didn't include the introduction of the company due to the short time for this presentation, but Alfalaval has three main divisions, and I'm representing the marine part, a small part of the marine division in this presentation. And my presentation will be in two parts. So the first part will be some kind of introduction of what we are doing and our activities on the boiler systems. And the second part will focus on the ammonia boiler system that can be used as a cost-effective and multi-purpose system on the ammonia vessels. Trying to figure out how to use this. Yes, so let's start. The Alfalaval has been in the boiler business for more than 100 years, and out of those 100 years, it has been mainly the oil fuel vessels, heavy fuel oil. That was the only fuel that was used in the marine vessels. And today we have a wide range of different fuels that can be used. The biofuel or low sulfur fuel, they can also be applied. And the LNG has been one of the first alternative fuel that was applied in the marine industry. And Alfalaval has mastered, and we were the first mover in introducing LNG dual fuel boiler systems. Fast forward that started from 2006. And fast forward to today, we have sold more than 600 boilers that are used for the LNG dual fuel operations. Methanol is more or less the same story. It has recently started, and we achieved the approval principle from ABS a few years ago. And it took a while to get the first the contract for the methanol dual fuel boiler. And so far we have 18 boiler systems that are applied in the 18 different vessels. And that is the only methanol boiler used in the marine industry today. One of the latest addition is the electrical element. So we have the boiler system that is a sort of a hybrid system. So it can fire the fuel to generate the steam. Also, you can use the electricity to generate steam if there is desirable. And we are working on the ammonia boiler system. We'll talk about the later part of the presentation. Yeah, this is the overview of our steam boiler systems and the other systems in the heating gas solutions that are focused on the heat generating solutions. So as mentioned, we have a conventional sorry about that. So the boiler systems that use they can be used for generating steam, there are also the waste recovery economizers that have the double energy in exhaust gas from the main engine and auxiliary engines and generating steam. So it's a very fuel efficient system. As you know, the cheapest fuel is the fuel that is not used. And, this is falling to that category. And the electrical steam boiler is also known to us. We have a solution that can be used for the retrofit applications as a separate the boiler systems. And apart from the steam systems, we also have applications for the hot water and drum oil based systems and the shallow tube heaters. And another good example of the environmental friendly system is the power generated from the waste heat from the waste thermal energy in the exhaust gas is using the technology called cycle, and our product is called EPOM pack. This is another way to look at the different steam boiler portfolio. So in the middle to the left, the three the boiler systems, there are conventional boiler types. So you consume the fuel to generate the steam. And in the middle to right side, there is the waste recovery economizers. So tapping the double energy from the exhaust gas and generate steam. And in the middle of it, it is the composite boiler, so that it has two separate sections, one for the conventional the fire section, and the other part for waste recovery. And to the far left is the electrical steam boiler, and so that only uses the electricity. But the ones from the second to the middle, they can be also applied for the electrical or the hybrid the steam boiler. Yeah. In addition to what we do in the ammonia boiler developments, we also have different segments, different business units of Alfalaval working on the ammonia the solutions. One of them is the fuel supply system, or we may also call it as a fuel conditioning module, FCM, that delivers the fuel to the engines and the fuel consumers. And our colleagues in Sweden, they are the champions of the plate exchanger that has been used for ammonia heat exchange for many, many years. They have different solutions. And the Framo is also one of the Alfalaval companies based in Norway, and they are working on the development of a submersible pump that can be used for the ammonia as a cargo and the fuel. And we used our testing training center that is located in Obo, where I'm based. And we used this is a place with more than 2,000 cubic meter footprint, and we have many different equipment installed in a working condition. In Alfalaval, we have more than 20 different solutions that can be used in the marine vessels, and many of them are installed in the testing training center together with 2 megawatts 4-stroke engines that will take the exhaust gas from the engine to the many different type of the tests for the different type of equipment. And this is where we tested the methanol boiler, and this is also where we will test the ammonia for the further development. Until today, we have finished the model testing in the laboratory scale, and we are moving on to the real scale the boiler test. In this, because of the characteristics of ammonia, we are taking a very careful steps, as many other companies will do. So we are moving from a very small size to a full scale in a gradual manner. So now I'll move on to the second part of the presentation. And we try to put ourselves, when we first look at what are the systems that will be interesting for the customers, being ship owner as well as the shipyard. And one of the first thoughts is that when the ammonia is used in the vessel, you will have to change the engine, and you will have to have a fuel system, storage, supply, and so on. There will be the extra costs. And the second thought is ammonia comes with a low flash point, though it's easier than the LNG. Still, it poses the challenges, and it's a toxic gas, so you will have to have extra equipment to handle the ammonia in a safe manner, which will again mean extra cost. It's not only the level of cost, because the availability of ammonia will also be limited for at least a certain period of time. So the vessels, they will be built today, and some years after, it will be a dual fuel vessels, which means you will have to keep all the equipment as in the vessel today, and you will have to add and find a space for the extra equipment that comes in. So there will be the extra space will be needed. So for the ship owners, it will also mean that they will have to probably compromise the cargo space. So our conclusion in this thought process is we need to come up with a cost-effective solution that will reduce the burden of extra cost, and that can be multipurpose. So you don't have to, the system that can use in both a dual fuel operation and also being used for different application can be a good solution. And our answer was the ammonia dual fuel boiler. What you see is probably the same as what you have seen before on the different steam boiler product. And what we have on the screen is the composite boiler that has the fire section and the waste recovery section. And that, in the middle of the slide, that parts will be the same. So you keep the boiler, or at least in terms of dimension, in terms of space requirements, it will be the same. And then what you will add is the ammonia valve unit or gas valve unit, or whatever it's called. So similar to the fuel valve tray that's used for the engine. It comes with a little bit of space requirement, maybe one square meter or slightly higher or something like that. That's basically it. And the extraction fan unit is also required according to the ICF code. So you're adding very little space. And apart from the steam generation, which is the core function of the boiler, it can also be used to remove ammonia in the purge gas. When the engine stops and when the engine changes the fuel, then as Mr. Kim presented just before, the pipeline between the fuel supply or even from the fuel tank to the engine and the return part will need to be flushed with the nitrogen. And some part of it will vaporize, and some of the gaseous ammonia in the piping system will need to be treated before ventilated. It can be brought to the boiler and be incinerated with the burner. And you don't have to consider this additional space for the scrubber or other type of single-purpose incinerator or the water tank. So there's a very limited space required. And unlike the water-based solutions, we'll be able to remove almost 100% of ammonia. And it doesn't produce any byproduct or waste. And another interesting example here is that the boil-off gas can also be consumed by the boiler, which is already a known technology in the LNG application. And the ammonia, although the ammonia doesn't require the heating up by a very large degree, but still, as Mr. Kim just explained, it comes with a very low the low energy content in it, so the flow to the engine is going to be a lot increased, and it will require heating up from the whatever temperature that is the ammonia is stored, which will most likely be minus 30 degrees or lower, according to the ITF code, the interim guideline, and then probably up to 30 degrees or something. So in this example, we have a theoretical case of a vessel that has the 1 ton per hour steam demand. So thermal demand by the vessel is 1 ton. And we have we look at the different type of the engine performance. And in this case, in this particular case, I cannot disclose too much details, but in this case, we were able to generate 450 kilogram per hour steam by tapping the exhaust gas from the main engine, which means remaining 550 kilogram per hour of the steam will need to be generated by consuming the fuel. And in this case, the boil-off gas can also be the fuel. So you'll be able to reduce the fuel amount of the fuel used to generate the heat, but at the same time, it will also mean as the boil-off gas is handled by the boiler, that you don't have to reliquefy those boil-off gases. So you can switch off your reliquefaction system, so electricity can be lower. So your the fuel economy on the vessel level can be more optimized. This is how the vessel may be configured without having the ammonia dual fuel boiler. So you have the ammonia storage tank, and they take the ammonia from the tank to the engine by the fuel gas supply system. And when the engine shut off, the fuel changes, of course, then you will have to take the vent and the purge flow to the ammonia recovery system. It can be the knockdown drum, it can be it's a pressurized tank, or it can be whatever type you want. And then after that, it will have to go through ammonia release mitigation system, they normally call it a vent treatment system. And that is probably the water-based solution, like the water tank or scrubber system, whatsoever. And they can be ventilated. And if you want to have a, let's say, more efficient system in terms of size-wise or process the efficiency, you may want to add an SA tank to improve the efficiency. Either way, whatever waste material that's generated through this process will need to be contained in the holding tank, because there is the discussion around this. But if you want to preserve the environment, that's also why we are discussing the ammonia as a fuel. Otherwise, we would not be talking about this. And in that case, the holding tank will be needed, so ammonia will need to be safely disposed to the shore or any other place where it has the handling facility. When you have the ammonia boiler, then it goes like this. So you can handle the boil of gas. Also, the fuel can be supplied to the ammonia boiler to generate the steam, the carbon neutral steam in that case. And the vent or the purge flow can also be handled when the ammonia, the purge flow goes to the gaseous state. And if it happened to be that the water-based system has been used, it can also be consumed and incinerated by the boiler, by the pure firing. And if another interesting concept here is if you want to lower the amount of the fresh water used in the water-based mitigation system, then you can also use the wastewater recovery system, where you will vaporize the ammonia in the water by heating up, and we use the regenerated water back to the water-based system. Then by doing that, you can lower your fresh water consumption. And at the same time, the vaporized ammonia can be consumed by the boiler. This is to summarize the different modes of ammonia boiler. So the steam that can be generated by the waste recovery system. It doesn't matter whether the main is on the fuel oil mode or ammonia mode. The steam can also be generated by the combustion of the boiler. And here we can use both fuel oil and ammonia once again. And when the boiler is used to boil off gas management or the tank pressure management to a more correct way, then it generates both heat as well as it ensures the safety of the vessel to keeping the tank pressure at the right level. As a safety system, the purge flow that can also be handled by the boiler as the firing with the flame formed by the fuel oil. In the same manner, for the within the capacity of the burner, you can also take the tank emptying mode. When the vessel goes to the dry dock every 5 years or so, then you will have to empty the tank, and in that you can only reduce up to 2% of the tank volume because of the pump capacity normally, and that 2%, the remaining 2% will need to be vaporized and pushed to the vent masks. And in that case, we can the boiler system, given the capacity is right, can also be used to that function as well. And if the waste water has happened to be generated, it can also be consumed by boiler. To sum up, we see the boiler system is actually has a potential to be the truly multi-purpose system that can be used in a different mode as we just talked about. And it's not just the functionality, but it also has the possibility to safely remove and efficiently remove all the ammonia that's in the unwanted the substances, and it's not generating any waste as a byproduct. And you will all be able to do that without finding the space. So in that sense, your cargo space doesn't need to be compromised. And as a shipyard, you don't have to find the space for the extra equipment. So your piping arrangement can also be optimized. That is all I have for this presentation. Thanks very much.
도에서 혹시 질문사항 있으시면 지금 마이크 질문을 한국어로 하셔도 됩니다.
한국어로 해서 편한데 그 말씀 잘 들었고요. 제가 지금 보일러는 LNG 생각에서 통상적으로 압력 컨트롤용으로 쓸 수밖에 없는 상황 때문에 GCU나 컴바인 보일러가 있는데 지금 암모니아에 굳이 보일러가 있어야 되냐, 압력 컨트롤용으로 아니면 추가적인 독성도 있고 여러 가지 고민할 게 많은데 그 이슈 하나, 또 하나는 아산화 질소라는 엄청난 부동이 나올 것 같은데 거기에 대한 대안이 있는지 두 가지를 궁금합니다.
일단 첫 번째 질문에 답을 드리면 일단 LNG 선에 적용된 경우는 그 GCU로 적용된 경우가 생각보다 적습니다. 일단 그 엔진이랑 같은 퓨얼을 쓰기 위해 LNG 듀얼 퓨얼로 가는 경우가 더 많고요. 네, 그래서 GCU 펑션이 꼭 필요해서라기보다는 그 오퍼레이션 상의 이점 때문에 한번 그 LNG 듀얼 퓨얼이 사용된 경우가 더 많습니다. 그리고 두 번째 질문에서 그 N2O 말씀하시는 건가요? 예. N2O는 거의 나오지 않는 것으로 저희 보고 있습니다. 저희가 그 정확한 테스트로 결과를 보지는 않았기 때문에 지금 테스트가 더 진행될 예정인데, 그래서 그 부분을 저희가 봐야 되겠지만 theoretically 봤을 때는 이게 그 N2O는 거의 나오지 않는 것으로 예상합니다. 암모니아 스위프트 같은 경우도 거의 없을 것으로. 아니요, 톡식 가스가 이 보일러 그 더블 옥시데이션이 되는 거죠. 보일러를 통하기 때문에. 그래서 예.
혹시 다른 질문 있을까요? 만약에 없으시면 제가 그러면 그 통상적으로 이제 그 노멀 오퍼레이션 할 때 우리가 이제 아모니아 슬립이 이렇게 나올 수 있는데 LNG나 또는 이제 포스로크 엔진과 마찬가지입니다만 그때는 아모니아 슬립 양이 얼마 안 될 걸로 보여서 그러니까 보일러에서는 어떤 부식의 문제라든지 이런 것들은 좀 조금은 걱정을 갖다 덜 하셔도 될 것 같은데 이게 어쨌든 보면 이제 아모니아 모드에서 디젤 모드에서 아모니아 모드에서 디젤 모드로 갈 때 디젤 모드에서 아모니아 모드로 올 때 이렇게 보면 이제 트란짓 오퍼레이션 할 때는 이게 아모니아 슬립이 상당히 좀 많을 것으로 예상이 됩니다. 그래서 이걸 이제 야드의 베이프 프로세싱 시스템이나 이제 그걸 통해서 1차적으로 처리는 하겠지만 그래도 언익스펙티드하게 우리가 봤을 때는 아모니아 슬립이 이렇게 좀 한 부분 좀 이렇게 조금 극단적으로 많이 나오는 때가 있는데 그걸 혹시 그 디자인하시면서 고려를 하고 계신지에 대해서
일단은 암모니아 자체가 있는 것만으로 문제가 되는 부분은 없어 보이는데요. 암모니아와 함께 무엇이 같이 오는지가 되게 중요한 거죠. 그래서 어떤 케미컬 리액션들이 일어나는지를 먼저 봐야 되고 그 부분이 정확하게 나오면은 저희가 이제 고려하고 또 검토를 할 수 있겠지만 지금 현재 암모니아만 가지고 뭐 30 ppm, 100 ppm, 뭐 220 ppm 이 정도 수준의 그래서 과연 그 메테리얼에 문제가 될지 안 될지를 논의 드리는 건 조금 어렵습니다.
예, 알겠습니다. 그러니까 아마 그 R&D 테스트 하시면서 좀 이제 그런 것도 좀 고려를 해주시는 우리 업계에서 서로 그 도움이 많이 될 것 같습니다.
고맙습니다. 정보 부탁드립니다.
예, 알겠습니다. 고맙습니다. 아, 예.
예, 고맙습니다. 지금 이제 그 DF 엔진을 사용하는 경우에 추가를 해주셨는데 구태여 만일에 지금 DF를 해서 어차피 지금 중류를 쓰잖아요. 배에서도 중류를 쓰는데 구태여 그 아모니아 DF를 해가지고 그 보일러 자체를 아모니아에 대응해서 만든다는 게 과연 그게 경제적일지 저는 좀 의심이 좀 들거든요. 그런 면에서 한번 이게 그러니까 기존에 그냥 중류 보일러가 아니고 아모니아 보일러를 하는 게 더 경제적이다. 우리가 그럴 수 있게 생겨서 좋다는 그런 걸 설명 좀 해주시죠.
네, 일단은 경제적인 측면으로 보면 지금 메탄올 케이스도 그렇고 아모니아 케이스도 그렇고 이런 선박을 얘기하는 것 자체가 일단 네이센스하지 논의 대상이 되지 않는 것을 보입니다. 왜냐하면 이 모든 것은 다 디카보니제이션, 탈탄소화 그게 있기 때문에 일어나는 일들이고요. 그 와중에서 이제 메탄올 케이스 같은 경우 저희가 아까도 보여드렸듯이 이제 총 한 18개 배밖에 적용이 안 됐습니다. 그 지금까지 나온 메탄올 배들이 아마 200척 정도 되지 않나 싶은데 200척 좀 넘었는데 그 정도 되는데 거기서 이제 적용된 케이스가 그렇게 적었듯이 메탄올에는 그 세이프티 측면이라든지 또는 이런 테이크 프레셔라든지 또는 펄치라든지 이런 쪽에 이용될 그 필요가 없었기 때문에 보일러가 고려 대상이 안 됐습니다. 대신에 지금 암모니아 같은 경우는 그 메탄올보다 훨씬 더그 스트링전트 리퀘어먼트들이 많이 생겼잖아요. 그 인테리어 가이드라인에서도 그 벤트 트리트먼트는 항상 그 벤트가 절대 있어서는 안 되고 그 벤트는 항상 트리트돼서 나가야 되고 그다음에 그 나갈 때는 220 ppm을 맞춰야 된다. 일단 이 정도까지 정리가 되어 있는 상태인데 이 200 ppm, 220 ppm을 맞추기 위해서는 뭔가의 새로운 시스템이 들어가야 되는 거죠. 그 새로운 시스템이 들어갈 때 기존에 있는 시스템을 multipurpose에서 쓸 수 있으면 그게 바로 코스트를 절감할 수 있는 방법입니다. 네, 제가 말씀드리죠.
예, 그 점에 대해서는 조금은 이해는 되는데 어차피 지금 나중에 하주 같은 경우는 스코프 3 같은 경우도 적용될 거 아니에요. 그럼 그 어쨌든 복잡한 시스템을 만든다는 것은 근본적으로 만드는 과정에서 CO2가 발생될 거란 말이에요. 그런 걸 고려한다 그러면은 과연 그 자그마한 보일러 때문에 또 복잡한 시스템을 이어가지고 돈을 더 들여서 한다는 게 과연 메리트가 있을까? 그래서 그런 면에서 만약에 후천 지금까지 판매될 실직이 있으니까 그게 국민거수도 마찬가지로 어떤 그 코스트라든가 CO2 발생량 같은 걸 분석했을 거란 말이에요. 그런 실직했을 때 그게 실제 메리트가 나옵니까?
그 일단은 판매 실적은 없다고 말씀드리고 싶고요. 이게 암모니아라는 게 지금 다 전체적으로 다 디벨롭하는 과정에 있고 그다음에 현재까지 룰이라든지 이런 쪽에서 적용하는 부분들이 명확하지 않았기 때문에 그 어제 미포에서도 발표를 해주셨지만 그 기존의 그 암모니아 캐리어 적용된 경우에는 이런 시스템이 들어가지 않았습니다. 그래서 그런 부분들이 고려되지 않을 부분들이 있지만 이제 룰이라는 게 이제 그 인테림 가이드라인이 지난달에 이제 완성이 됐고 다음 달에 이제 어프로될 예정인데 이런 것들이 진행되면서 이제 이 메리트들이 좀 더 인식이 될 것 같아 보이고요. 그래서 곧 그 저희가 이제 수준하지 않을까.
네, 저는 그 말은 비판적으로 했지만 검토하실 때 그런 것까지도 검토해서 고객님들 엉뚱한 질문을 했을 때도 적절한 답변이 되면 좋지 않겠나 그런 차원에서 질문을 드렸습니다. 고맙습니다.
네, 고맙습니다. 네. 수고해 주신 우리 알파라발의 덴마크 헤드컷에서 근무하신 우리 데이비드 선생님 박수 부탁드리겠습니다.